Good afternoon. I'm Tim Smith, and today we're going to be continuing our UPD product series with controls and indicators and some general maintenance guidelines. And hopefully this will allow who's ever observing to be able to look at ride-through indications on the units and be able to tell some basic troubleshooting indications and the unit state of health. First, we're going to start off with some basic UPD operation and function, and then we're going to get into controls indication and some basic maintenance considerations. Part 2 of this presentation will be more detailed troubleshooting guidelines, and will also take us deeper into the way the ride-through functions and some signal tracing. Pretty much everything we cover here is outlined in the manuals, the owner's manuals, which are online on each of the product pages, and it has pretty much all the information I'll be covering in this presentation, and part 2 also. First, in the beginning of the manual, there outlines the part number, which gives you some basic information about what the ride-through unit's capabilities are, and also it's very important for ride-through to know the line voltage. And the line voltage codes are outlined, which are indicated in the model number. This will tell us what the threshold setting should be in relation to the DC bus, which is also in relation to the AC input to the ride-through and the VFD. There's a specification page that gives you a little bit more detailed information about the unit capabilities and some of the features too, and limitations for the ride-through units. Just a little review from our last presentation about connectivity. There's many ride-through solutions out there, and a lot of the solutions that are out there on the market right now connect to the front end of the drive, as opposed to the Bonitron UPD products, which are parallel to the drive, and this has many advantages that we covered in the first presentation. And there's only one conversion, AC to DC, and the voltage regulator booster will output DC to the DC bus of the drive. Once again, DC bus connections are critical for using UPD products. Okay, we'll start with unit selection just briefly, and just a review here as to how to select the ride-through, and we're already past that. Now we're going to talk about what the customer is going to see as far as indications and how to monitor unit state of health and what the indications mean, and then we talk about some of the ancillary units and their indications and the display. So once again, on the left we have sag protection, which is a single unit that can be used to correct for sags up to 60% for 2 seconds. And also you're going to use a kilowatt rating, and the kilowatt rating corresponds to whatever the power requirement is to that the motor requires during the process, during the ride-through process. So in other words, we size to the actual motor ratings of whatever motor is tied to the VFD that's tied to the ride-through. Now some operation and functionality for the 3 different versions that we have, starting with ride-through sag, which is the least, I don't want to say complicated, but you only require 1 unit, and the unit connects directly to the AC line and the DC bus of the drive, as you see right here. These units, the single units, do not require any additional ride-through storage. but we can use this sag ride-through unit and add ultracapacitor energy storage. But the limitation of this unit is it can only work for 2 seconds. So it will only cover up to 2-second full outages, which is ultracap energy storage. If you're tying the sag ride-throughs to multiple drives, we would size the sag ride-throughs to the total drives on the common bus. One critical thing about sag ride-throughs is that any of the drives that are tied to the ride-through unit must be on the same AC feed as the ride-through unit's on, and all of the drives are tied to. Reason for this is we're using the AC line, or the remaining AC line, during a sag event to boost into the DC bus. So there has to be some remaining AC line to use just the single unit sag ride-throughs. And it's at least 40% cumulative across all 3 phases. You can lose one single phase AC as long as you have 70% remaining on the other 2 phases. There has to be something left for the ride-through to boost without energy storage. This shows a picture of the DC bus, the AC feed on top to the VFD during the sag. And as the AC sags, the DC bus begins to collapse, and in the bottom part of the O-scope display, you'll see VFD DC bus without ride-through. This shows a sag, and then we add ride-through to it, and as you can see, the AC line is still sagging, but the DC bus has only a momentary dip before the ride-through reacts, but the drive does not even see the change from utility power to ride-through. So there's no change in speed or torque of the motor that's running the process. Now, basic ride-through booster functionality. All the ride-throughs pretty much function the same way, all 3 versions, the outage ride-throughs and the sag ride-throughs. The difference is where it's getting its source to boost from. As with the sags, you get it from the AC line, the remaining AC line. During a power quality event, the internal DC bus of the VFD is going to drop. When this level meets the DC bus threshold voltage of the 3460 or M3534, functionality is basically the same for both units. Power is delivered through blocking diodes to hold up the voltage of the VFD DC bus. The 3460 regulates and boosts the input voltage of the drive at a constant voltage. In standby mode, when the incoming AC power is normal, the 3460 power consumption is minimal, as we discussed in our last presentation. There's parallel stages in the ride-throughs when you get over 50 kilowatts, so even if you do lose one stage, there is still some ride-through capability. It's degraded, but as long as you have one stage left, it will boost with that stage. So there is redundancy even within the greater than 50 kilowatt 3460 units. So if we look at the circuitry on the left, you'll see inductors tied to the IGBT, and you'll also see the blocking diodes that hold off the ride-through when it's not riding through. So in other words, the inductor stores energy when the IGBT turns on and chops. This is a basic chopper circuit. The IGBT turns on at the preset DC bus threshold. And once again, that's critical that we know the AC line, because the DC bus is related to the AC line, as we know. The diodes become forward biased and feed the ride-through DC bus, which is connected to the VFD DC bus. When the ride-through event ends, the DC bus returns to normal level from the AC line. Then the ride-through turns off and sits there in a static state. And that's the basic function of the SAG ride-throughs and the outage ride-throughs. And as I said, the only difference is that it's where we're getting the energy to feed the voltage regulator booster, which feeds the drive. Now we're talking about full outage ride-through. And what happens is once the low bus threshold is reached that the ride-through turns on, instead of pulling the remaining AC line and boosting that 2-to-1 into the bus, we pull from a battery bank. So once again, there's no efficiency losses with double conversion or anything like that. So as you can see, this is the schematic. The AC line is now tied to an isolation transformer, which feeds the charger, and the charger charges the energy storage, and in this case we're looking at battery energy storage bank. And the voltage regulator will pull from the battery energy storage bank. That's why sometimes it gets a little confusing, because internal to Bonitron we call this DC ride-through, and we call the SAG ride-through AC ride-through, because of the way the power is sourced, or the energy sourced from whatever energy storage we're using. And once again, it will keep boosting until either the 2-second limit is reached in the SAG ride-throughs if you're using ultracapacitor energy storage, or until the battery is down to a certain level, and it will, or the ride-through event is over and the bus threshold returns to normal because the utility power is back to normal. The ride-through once again turns off, it being a passive device. That is pretty much the functionality for both the UltraCap and the battery ride-throughs. Once again, the only difference is we're using a energy storage bank, and the SAG ride, or the booster voltage regulator, is pulling from the energy storage. When you are above, when your requirement or specification is greater than 2 seconds, and you do have the option to use UltraCaps up to 5 seconds, but then we would use the more heavy-duty booster. The differences between the SAG ride-through booster and the M3460B, or what we call the battery boosters, is just that the Bs are rated for a higher duty. They are standard 4 minutes, but we can derate them up to, I've done 4 hours before. So anything between would be the battery boosters. But if you're above 5 seconds, we would recommend battery energy storage, only because of the economical issues with UltraCaps. And as you can see, as far as connectivity, it's the same with the UltraCaps and the batteries. The charger isolation transformer connects to the AC line. The isolation transformer from the AC line feeds the charger, which feeds the energy storage, either UltraCaps or batteries. It's the same thing with both. There's just some charger differences between the energy storage. And that's basic functionality. In the next session, I'm going to get a little more detailed and provide some signal tracing. But for right now, we're just talking about indicators and how to visually inspect the ride-through to determine unit state of health. Inside the M3460s, there is 3 major boards that have LEDs that will allow you to be able to observe unit state of health, and if you have a fault indication, or if you're just doing a quick check. Usually these are open chassis units and the LEDs are visible, but you would have to open the cabinet to be able to get in and look at the actual circuit cards on the open chassis 3460. I talk about the 3534s a little later. There's some differences. There's no card indicators on those units, and the 3460s is what we're discussing in the next several slides. The three cards are the C1 control board, the M6 interface card, and the D5 power supply card. I'm going to review the indicators on all three cards, and once you have a clear understanding of what the indicators are on all the cards, it really helps you get down the road if you're having an issue with the ride through or if you have a fault you're trying to determine. In most cases, if there's any serious troubleshooting, we have factory repair depots globally, but for the most part, the actual end user or maintenance guy can go through and get some basic information to be able to tell the technicians, unless he is a factory service trained rep. So the first thing we're going to cover is the control board, which is the brains of the unit, the heart of the unit. There's several indications on here that will help you determine what your unit status is. The first ones are the plus 15 volts and negative 15 volt lights that illuminate red when the internal power supply is operating properly. The power supply provides the voltage. The 15 volts plus and negative provides the internal stage current sensor status. If 15 volts is being applied to the internal stage current sensors. Also on the C1 card is the ride through ready indicator. Ride through ready light will illuminate red when the 3460 has been enabled and there are no faults. This can be used as a general status indication because most of the faults feed this light. So if this light's out, if you look at the manual, it will tell you what some of the reasons that the ride through ready light does not light properly. Also on the control card is a pre-charge complete. The pre-charge complete light illuminates red also when the M3460 internal bus capacitors. This has nothing to do with the drive. This is just indicating that the internal ride-through bus capacitors have been pre-charged. The blown fuse indicator on the C1 board illuminates red when an internal IGBT stage fuse has been blown. As I said, there are stages in the ride-through when you get over 50 kilowatts. So it's one stage per 50 kilowatts, and each stage has signals that will feed this light, and that tells you the IGBT stage fuse has blown. Then we have the ride-through active light, also on the C1 board. Ride-through active light illuminates red while the M3460 is regulating the DC bus, or when the 3460 is put into test mode. If the 3460 is unloaded or lightly loaded, this light may not illuminate. It looks at the difference of the boosting of the DC bus, and it tells you that the ride-through is actually boosting into the DC bus. What sometimes we run into is that the light may not indicate, because when you actually do a ride-through test, if the DC bus level is already high, close to the overvoltage trip, it will not allow it to boost to an overvoltage fault. The test light will illuminate red when the 3460 is put into test mode. Once again, depending on the DC bus level, there may not be enough for it to boost high enough to be able to indicate. Now, one of the most critical components on the ride-through control board is the DC bus threshold adjustment R7 potentiometer. The ride-through voltage regulator control circuitry reacts to the resulting lower DC bus level during a loss of input AC to a VFD. So in other words, this adjustment is very critical as far as telling the ride-through when to turn on in relation to the DC bus. The ride-through DC bus threshold is a factory set, and once again it is in correlation to the corresponding AC line voltage, which varies throughout the world. The DC bus threshold can be adjusted if necessary, but only by factory trained authorized personnel, and that's, as I mentioned earlier, we have global facilities that can handle this. And we can also provide information and training to specific companies that feel that this has to be accomplished. Now we're going to talk about the M6 interface board. And first we point out the no fault light. The no fault light will illuminate green during normal operation. It goes out with a ride through ready fault, overtemp fault, or voltage fault after a 3-second delay. So in other words, if everything's good to go, this light should not be lit. So just during normal operation, you'll see this light unlit. So when it lights, that means there's an issue and something that needs to be addressed. Now the power supply board, output under voltage indicator LD1. The output under voltage light will illuminate green under normal conditions. It will go out if the drive DC bus drops approximately 35 volts below the threshold setting. This tells you that the ride-through is just not riding through or boosting. It's not regulating the DC bus, and an undervoltage fault on the attached equipment is possible. So in other words, if it's not boosting, you're going to see an undervoltage fault on the VFD. This light is labeled on the circuit board as bus OK. Also on the D5 power supply board is a 23 volt plus and negative voltages, and it will illuminate when 23 volts is available under normal conditions. And there's also a 23 volt DC that is indicated by LD2 as a 23 volt DC isolated signal. This signal is used internally to the ride-through event to provide 23 volt DC power. And those are the main 3 circuit card indications. And now we're going to talk about a little bit of the differences between the M3534R indicators. The M3534R is the equivalent of the 3460, with the only difference being the kW capability. So in other words, it functions the same way as the 3460. For sag protection, the 3534R will provide 2 seconds, 50% sag protection as the 3460s do. The difference is the 3534s are a single wraparound chassis enclosed unit, and they will handle 0 to 50 kilowatts for a single unit. The 3460s start at 50 kilowatts and go to 250 kilowatts per single unit. Once again, there are no internal card-mounted indicators available for observation. But the 3534R chassis LEDs will allow you to have some idea of what the status of the unit is. You have a ride-through active light that should light during a sag event when the ride-through is actually riding through and providing DC bus voltage. Overtemp light lights when the unit's internal heat sink is above 65 degrees centigrade, 150 degrees Fahrenheit. And then when you initially power the unit, you're going to see the green light, which is the power light. That should turn on right off the bat when everything is energized, regardless of ride-through event or not. Now, with the outage ride-through, there are some ancillary units that are required. The one we're going to talk mainly about is the 3528 charger. It's a voltage-limited current source, and it's used to charge batteries in the ultra caps or electrolytic caps, which we use all three energy storages, and that's dependent on your specification. So one of the advantages of Bonitron is we can actually size the energy storage to the exact requirement. A lot of ride-through solutions, say UPSs, you're stuck with 5 minutes period, regardless of whether you need just seconds of backup. They don't provide any lower than 5 minutes, is what I've found. The M3528 battery charger can charge battery strings or ultracapacitor strings from 175 to 600 volts DC. In the manual, you'll have a part number breakdown that will help you understand what the unit capabilities are. And you also, once again, have the line voltage designators, which are in the part number, which are very important to ensure we have specified the right type of charger. This shows the charger model numbers and capabilities. Also battery bank values and watt loss chart too, if you're putting the unit into an already established cabinet with the rest of the ride-through. Okay, indicators on the battery charger. Once again, there's only a couple ways that you can monitor the chargers. There's no internal card LEDs, but there's several additional LEDs on the charger that help you to determine unit state of health. They're located on the front panel. And a warning, important note, to identify LEDs and ensure understanding of what the indication means only. For routine equipment status observation, adjustment of any of the associated parameters should be done only by authorized factory trained personnel. The reason for that is this is going to affect your charging current and battery equalization and things like that. So this training today is basic indicators and controls for ride-through school. There's much more involved to it. This is just for the casual observer there or maintenance guy that's going to be monitoring the unit to be able to have a little bit more information when he talks to the tech who may be trying to resolve a problem with the charger or the ride-through system. The first indicator we want to discuss is the power indicator. Illuminates green when internal power supply is operating properly and power is applied to the ride-through system. Over temp, the light illuminates red when the charger M3528 heatsink is above 65 degrees Fahrenheit. The M3528 will not operate when the over temp light lights. The light turns off when the heat sink temperature returns to a safe level. Current limit, this light illuminates amber when the charger is operating at full current or in constant current mode. It's a normal condition. It stays on until the charger output begins to reach the voltage set point. The charge indication, this light illuminates green when the 3528 is actively charging. And the equalized light, this light illuminates amber when the 3528 is in equalized mode. This is only available on the K7 chassis. And this light indicates battery equalization. So this can also be viewed at the DD4 display. As far as routine maintenance, all of the Bonitron ride-through products are what we call minimal maintenance type products. There's not a lot you do on a routine basis other than look at the indicators to determine unit state of health. You know, basic things like keeping the cabinets clean, free of dust, stuff like that. But as far as any specific maintenance for the Bonitron products, the ride-through UPD products, there's no real specific maintenance other than ride-through test. And the ride-through test can be done online too, or actually when the system is up and running, because it doesn't, it just boosts the DC bus a little bit to ensure that the booster is working properly. Now we're going to discuss the DD4 digital display. This is a very good tool in addition to the indicators we discussed for troubleshooting and system status and ride-through event status. There are 3 parts to the kit. If it's ordered separately, if it's ordered in a system, all these are included in the ride-through system, connected and ready to go to the ride-through units. And the only connections for a cabinet system are to the drive and the in front of the drive, the AC line. The kit includes the DD4 HIM, or human interface module, the actual display, and we do provide these kits loosely if you're just buying the open chassis units, or if you're just buying the modules for a full outage system. It also includes the i3 interface module, which is standard in the 3534s now. And there's a current sensor network that has to be configured, as you see in the drawing, which goes with the whole kit. This is all included in a separate kit that can be provided with the modules and a remote display cable that can go out to the front end of an already installed cabinet. Let's say the customer may want to use his own cabinet, his drive cabinet has room for the system, so we just need to know the cable length for that. The DD4 display gives the users real-time information about ride-through system functions, can be used to monitor and present power quality issues. It can cause process disturbances and production loss. The DD4 display is almost a power quality monitor, but it does not look at power factor. History of power quality events is stored in the persistent memory for later analysis. And this will show you the parameters of the ride-through event. So this allows you to see what your utility power is doing wherever this is connected to. The AC, or the 3660 DD4, is designed to monitor and display information about the ride-through system also, such as the present values of the system voltages and currents. So it's not just monitoring the actual ride-through unit, it monitors around the ride-through unit. In other words, DC bus voltages and AC line and things like that. It will save the 30 most recent power quality events, records information such as time event, duration of the event, and the voltage levels during the event. So it does give you a good picture about what your utility power is doing once it's installed. As far as the actual display, information is presented to the user via 4-line 80-character display and a set of 3 LEDs. Combined with the simple menu-based interface. So you can actually use this for some minimal training. You can operate the display without affecting the ride-through unit depending on which menu you're in. Isolated customer connections are available for remote controlling of enable and disable signals, equalize and test functions, as well as fault notification. So we can send outputs to a Ethernet system, or there's I/O outputs that you can actually either enable the ride through depending on your system configuration, or send an enable signal from the ride through to enable a drive. This lays out, and as I said before, all this information is in the manual in one shape or form or another. And this shows the part number breakdown for the DD4 digital display. And the last two numbers actually indicate the type of current sensors that you're going to be needing for whatever system you got. The current sensors are rated by current. So in other words, there's going to be different versions depending on the size of the ride-through or the rating of the ride-through. And we designate this by the numbers after the dash, after the DD4. And if there's a C there, that means there's a charger included in the system. If there's an X there, that means it would just be the SAG ride-throughs with no charger or external energy storage. This just shows specifications. And here's the current sensor networks. And as you see, these are located throughout the system, and they feed the display. And these are located in the DD4 manual that comes with the systems or with the DD4 display. This can also be found online on the undervoltage products page. And as you can see, the current sensors monitor the DC out from the ride-through, DC storage, and the charge current. And this will feed the display to be able to give you indications of all of these different functions. Once again, all this is included in the display manual. As far as functionally, the monitors the ride-through system completely. You're going to have LED indicators that pretty much correspond to the basic indicators, and they will give you unit state of health. And you're going to have a ride-through ready, ride-through active, and a fault indication. Also, there's push buttons that will take you through the different menus. As I said, this is just indicators and basic connectivity. In the next presentation, we're going to be going through the different displays of the DD4. The far left indicator is the fault indicator. Detects a system fault, turns on, and the fault state will be displayed in the LCD window. If multiple faults are detected, the display scrolls through each fault automatically. It says 100, but actually now we only provide 30 fault states. The equipment doesn't fail that much, so never get to 100. And they'll be saved into persistent memory. So in other words, you can go back and review the faults and the different parameters that the faults indicated. So at a later date. Faults can be cleared either by a key combination on the front panel or by toggling the enable input to the appropriate component. When a power quality event occurs, the yellow status LED turns on and the display indicates that the ride-through is active. In other words, there's a ride-through event right now, the amber light is lit, and it's telling you that the unit is providing backup or DC bus voltage. When the ride-through event is over, it will turn off and go back to a static state. It allows also allows the user to initiate a ride-through test for preventive maintenance and to ensure proper ride-through operation is the case. So in other words, during test, it's doing a brief boost function, and the amber light will light indicating that it's actually boosting properly during ride-through test. The ride-through test is a preventative maintenance function, and it ensures the proper ride-through of operation. The user can also initiate a charger equalize cycle of a fixed length set from the display front panel too. This just summarizes the LED indications on one slide. You have red for fault, yellow for ride-through active, and green indicates that the unit's been powered up and everything's working properly. The function of each of the buttons below the LEDs depends on the active screen. For the menu screens, enter selects a menu option while cancel moves back to the previous screen. Up and down move the menu cursor. On screens where numbers are input by the user, the left and right buttons move the cursor while the up and down buttons change the selected digit. Enter stores a preset value while cancel undoes any changes. Depending on the type of ride-through, of course, if you were just using SAG and there's no energy storage, the buttons that would indicate energy storage levels and things like that, they'll have no function. As we have repeated numerous times, the Bonitron equipment requires very minimal maintenance. Connectivity is simple. Even the modules, if you get a modular system, the connectivity is pretty simple and very well defined in the manuals. Doesn't take any kind of programming unless you want to, change some of the parameters in it, which are factory set that don't usually need any kind of changing because we've already set it up for the type of system that you're requiring and set to your specification. So usually everything is set correctly, and very seldom do we have to go in and adjust potentiometers or anything like that when a new system is installed. As far as ride-through events, you can monitor a certain period of ride-through events, and you can also look at the total ride-through events from the factory. We logged one ride-through event during testing to show that the thing went out the door and it was working properly. Now, when we're talking about long-term full outage ride-through, over 2 seconds outages, you're going to be using the battery ride-through booster, what we call the heavy-duty booster, the M3460B. We can, so this also means that you're going to be adding energy storage to the actual ride-through boosters. So what this also means is that we can provide the energy storage, or if you have a good source for batteries that knows what they're doing, because there are certain things that you have to do with a battery cabinet that makes it a little bit different than normal electronics cabinets. So there's venting involved, and then there's also some hazmat issues. And usually with battery energy storage, there will be a maintenance plan that Bonitron does not provide. Usually that's up to the customer to figure out how they want to do their battery maintenance. And in most industrial applications, most plants I've encountered usually have some sort of battery maintenance program. The batteries that we use for the ride-through are standard, so they can fit right into the existing battery maintenance program. There's no special considerations. Another advantage to Bonitron battery systems is that we have found that our batteries last much longer because they're not series and there's not a constant AC voltage, line voltage being applied to the unit. as with series solutions, that input AC and output AC, such as UPSs or some of the dynamic sag correctors that are out on the market. So in other words, we don't beat up the energy storage, because a UPS is going to activate anytime there's an issue with the AC line. And also you have, transients or things that can affect the AC solution more so than the Bonitron parallel solution. Well, that's pretty much all I have. Any questions, please feel free to email us. And once again, go and look at the undervoltage web page. The manuals are there. There's introduction to Bonitron, and we also post these presentations on the website so they can be reviewed later and used for reference. Thank you, and good day.